Hello, welcome to r.t.p Academy. My name is Mike Warner, and in this video we'll be talking about chemistry. So in the previous weeks we have been doing so much of the chemistry, and also this is a continuation about the same thing that we've been doing. And I would like to say that if you're new to my channel, for the first time that you're watching this video, please don't forget to subscribe to my channel so that whenever I post any latest content on my channel, you'll be the first person to get a notification that we as a r.t.p Academy, we have actually uploaded a new video. So just click on the subscription button so that every time I post a video, you'll be the first person to check out this kind of a video, and you'll be the first person to see the first information that we unveil to you. So now, without much further ado, now let's just jump into our main video now. So this video is about the molar volume, okay? We'll be looking at the molar volume of gases, okay? Now, I want you to understand, for those of you who are watching this video for the first time, I encourage you to go back and watch some of the previous video that I did concerning the mole concept on how to calculate the mass of the given substance, either an element or a compound, and also how to calculate the number of moles in a particular substance or anything that you might actually be looking at, okay? Now, in this video, we will be talking about the molar volume. So what is the molar volume, and how can we, what do we mean by the molar volume, and what actually are we supposed to know, what things do we need to know under the molar volume, okay? So now, just a bit of introduction is that when you're talking about the molar volume, we are simply talking about the specific amount of volume a gas will occupy in a particular, environment, okay? So this is a standard volume of most of the gases that we know about, like oxygen, like the hydrogen, the nitrogen, the carbon dioxide, the carbon monoxide, and other gases that you might think of, okay? So the molar volume is just a standard volume of a certain gases, okay? So we are saying that this is the amount of volume So now what happened is that this is the amount of volume occupied by volume occupied at certain conditions, okay? So what we mean by certain conditions is that these volumes, they normally behave differently when you expose them to different conditions, okay? But now we have to understand what are these conditions that we're looking at, okay? So the first condition is that there is a condition called r.t.p and then also s.t.p. So what we mean by r.t.p, this means that we are talking about room temperature Okay, so we are normally looking at two things, okay? For example, like two conditions, that is r.t.p, room temperature and pressure, and then also standard temperature and pressure. So regardless of which condition you are looking at, okay, you should just know that whenever we are dealing with gases, okay, we must ensure that these gases, they have been subjected to certain conditions, okay? So we have to be specific at what conditions are we looking at. at what condition is the gas occupying a certain volume, okay? Is it at r.t.p, is it at s.t.p, okay? So each of these conditions have got the specific volume for which any of the gas should be able to occupy, okay? So room temperature. Okay, so now when you talk about these conditions that we are talking about, there is the r.t.p, which stands for room temperature and pressure, meaning what is the volume of the gas in a particular room, maybe where you're carrying an experiment, okay? Because you see, most of these gases, they can behave differently, okay? So depending on what are some of the climatic conditions, okay? Like in terms of temperature, which has a huge effect on the performance, or rather on the behavior of the gases. Okay, so we have to understand what is the temperature in that room, and then what is also the volume at r.t.p. And then also, now to simplify what we have talked about is that when you're talking about r.t.p, we are saying that you are looking at the temperature of the room that is at 25 degrees Celsius, or in kelvins, which is also another video that I'll try to make on how you can convert from kelvins to back to degrees Celsius, so of temperature. So 25 degrees Celsius in kelvins, it is just simply as in 298 kelvins, that is a capital K. And then the pressure is 1 atmosphere, okay? Since the gases they occupy, meaning most of these gases, they do occupy the certain atmosphere, okay? So the reference point we are given is that the pressure is relatively to the atmosphere, okay? In part of the biosphere in which that gas is normally, occupying. So 1 atm, which is just a shortcut of atmospheric pressure, or just the atmosphere. You can normally refer to it as 1 atmospheric pressure, okay? And then which is 1 atm. Now that number 1 atm is also equivalent to 101,325 Pascal. Okay, so one of the scientists, physicists that did most of the work on gases is Pascal, or maybe on forces of pressure was Pascal. Okay, so one of the French physicists or scientists. Okay, that the units of pressure were named after him. Okay, so 1 atmosphere, 1 atm is equivalent to 101,325 Pascal, or just Newton meter squared. Okay, now the volume at r.t.p is equivalent to 24 decimeter cubic. Okay, 24 decimeter cubic. Now I also want you to understand that when you're talking about volume of gases or liquids or anything other than solid, is that the volume can also be measured in liters. Okay, but we shall come to that when we come to the topic called dilution, concentration, and things like that. Okay, but just know that the units of volume at this moment of time is decimeter cubic, or cubic decimeters. So that's about room temperature and pressure. And then also about the s.t.p. The s.t.p stand for standard temperature and pressure. Okay, so wherever you go, okay, so you might go to Canada, you might go to Australia, you might go to Rwanda, you might go to Congo, you might even go to United States of America, or even Italy. Okay, so you discover that the standard temperature, okay, so meaning this is the international agreed upon, okay, kind of conditions of measurement that you must be able to know about. Okay, so the temperature is 0 degrees Celsius. Okay, that is in centigrade Celsius. Okay, 0 degrees Celsius, or 273, the absolute value of any gas, meaning the gases that when you draw the graph goes backward, like the negative, it reaches almost negative 273, meaning that is some kind of a coldness. Now the pressure is still the same in r.t.p and also s.t.p. And then, which is equivalent to that, 1 atmospheric or 101,325 Pascal. Okay, and then the volume at s.t.p is 22.4 decimeter cubic or cubic decimeter. So what is the volume? What is the formula that you can apply in order to find the volume of the gas? The number of moles, and then depending on which kind of the condition you are looking at. So let us see this simple formula, okay, that you can apply in finding the physical volume, okay, given the number of moles and also given the molar gas of the volume, meaning the gas with respect to what condition are you looking at? Is it s.t.p? Is it r.t.p? And so on. So the formula says that moles of the gas equals to physical volume. Okay, so the physical volume is that how much of the space will that gas occupy in a particular room or at any place in this world. Okay, and then the molar gas volume, of course, I've talked about, which can also be simplified to as the number of moles equals to the volume over molar volume, which you can just say over mv, okay, molar volume. Okay, so let us look at the examples and see how we can apply the formula that we saw and the formula that we talked about. Okay, so the formula for finding the physical volume that a certain gas will occupy at a certain molar volume is at s.t.p or even at r.t.p. So in this example, we are going to see how you can find the volume, okay, when you're given the number of moles in that particular gas. Okay, and by the way, this kind of examples or this molar volume, the subtopic of the mole concept, is normally referred to gases only. Okay, because it is very easy to find the gas, to find the volume of the gas than it is to find the mass of the gas. Okay, so these are the following examples. We are saying that what is the volume occupied by each of the following gases at r.t.p. So we have 0.25 moles of nitrogen, and then Roman numeral 2 moles of the oxygen. And then we've got the other example, which is saying how many moles of chlorine gas are present in 48 cubic decimeter of the gas at r.t.p. And then also the last one, but not the least, okay, how many moles of oxygen gas are present in 12 cubic decimeter of the gas at s.t.p. So make sure we understand at what conditions are the gases, occupying. Is it r.t.p? Then we think of the molar volume of the gas at r.t.p, which is just 24 decimeter cubic, or is it at s.t.p, which is just 22.4 cubic decimeter. And then once we figure out those kind of things or information we collect from the questions, then we'll be able to answer the questions and provide accurate and correct answers. Okay, so let us now dive into the answers at this moment of time. Okay, so what we need to understand is that first of all, we start by saying so we have the solutions. We have the solutions now. Okay, so for number one, okay, what we need to understand is that the condition is r.t.p, and then at this r.t.p, the volume is just the 24. Okay, so make sure you take note of the volume that you are looking at is 24 cubic decimeter. And then what else? N just simply stand for the number of moles of that particular gas. Okay, so N meaning the nitrogen. Okay, we are looking at the nitrogen. So N of the number of moles of nitrogen. Okay, so the number of moles is 0.25 mole. And then the molar volume, which is MV, the molar volume equals okay. Now what we need is meaning this is molar volume. Okay, so the molar volume. Now what we need is the volume of this gas. So it's a question mark. So once you do that now, it's just a matter of now what is the formula for that. So the formula will be N equals to the V over mv. Okay, so I have been given the number of moles, so you put this one 0.25. okay, or rather the best way you can do it is you make V the subject, okay, or maybe let me just where there is N you put 0.25, so 0.25 mole equals to V, since you are looking for V, over 24, sorry, so 24 decimeter cubic per mole. So per mole, meaning that 0.2 mole equals to the volume that we are looking for divided by the 24 cubic decimeter per mole. So now what you do is that this is the fraction, you say over 1, okay, and then you now cross multiply. So 1 times V, you get V, and then now 0.25 mole multiplied by 24 per mole. So what is going to happen is that this mole and mole will cancel, and then the answer that you get now is just a matter of now saying V, okay, so V equals to 0.25 multiplied by 24 . So this will give us so 0.25 multiplied by 24. So you just get 6 decimeter cubic. Okay, so the answer you get is 6 decimeter cubic. Okay, so that's how you can go about finding the number, the volume, the physical volume that a certain gas is going to occupy, and you can use that simple formula for you to get to 6 decimeter cubic. So now let us move on to the second one. So we are going to use still the same formula, all we just change now is the numbers, okay? Okay, so now what do you know about the second one? Second one is that we've been given the oxygen, and then the oxygen has got 2 moles, and we have the conditions at which this oxygen is occupying a certain space or anything like that, which is r.t.p, and then at r.t.p we do know that the volume is 24 cubic decimeter. So we are going to use the formula for finding the number, the physical volume, that is the gas you occupy. So this one is the number of moles is 2 mole, okay, and then the molar volume is still 24 cubic. And then what else? The volume equals to question mark. Okay, so we are looking for the volume, and that's how we can go about it. So the formula is number of moles equals to the physical volume over the molar volume. So now you make V the subject of the formula. Okay, you make V the subject of the formula. So this is going to be V equals to N times mv. So now V equals to 2 mole multiplied by 24 decimeter cubic per mole. Okay, so that's how you go about. So 2 mole multiplied by 24 cubic decimeter per mole. So per every 1 mole of the oxygen gas. And what you do is that this mole and that mole cancels out. Okay, so now what will happen is that 2 multiplied by 24 cubic decimeter, this is going to be this is 8, and then that is 4, and then you get this. Okay, so that's how you can find the volume of the oxygen gas that contains 2 moles. Okay, so that's how you can just do it. Okay, so now let's now move on to question 2 and see how you can be able also to apply the same concept. Okay. Okay, so let's now answer question 2A and B, and then we also wrap up our session, or rather this video. And before that, I'll also get quickly into the last part where you're given the mass of something and then you're told to find the gas of the volume, the volume of the gas, and etc, something like that. Now, so let's now jump into answering question 2A. So the question is saying how many moles of chlorine gas are present in 48 cubic decimeter of the gas at r.t.p. So still the condition is 24, the volume at r.t.p is 24 cubic decimeter. So take note of that. So we are saying that the number of moles, that is what we are looking for, and you put the question mark, and then we have been given the physical volume is that the volume is 48. Okay, and then the molar volume is 24 cubic decimeter at r.t.p. So take note of that. At r.t.p, the volume, the molar volume is 24 decimeter cubic, and so on. So therefore, this is going to be N equals to V over M over mv. So what you do is you are looking for N, so this will be N equals to volume, this one, then over this r.t.p molar volume, decimeter per mole. So this is going to be decimeter, decimeter goes. So remember, what you are looking for is the number of moles. Okay, so when you look at the units, this cubic